In the last video, at the end, I gave you two online references. One was to one source for 455 kilohertz ceramic resonators, and the other was to a schematic, and this is it drawn by hand because I drew it by hand. Then I highlighted items as I built the oscillator. What this is the 455 kilohertz oscillator, okay, and this is a twin T audio oscillator. Frequency I don't know, I didn't measure it, and I'll tell you in just a minute. And here's the circuit board that I built up, okay. Here's what it looks like on the bottom. This is just a proto board that, you know, I got a bunch of them, 10 of them I think, cheap off of eBay, and they come in handy every once in a while. Okay, here's the oscillator, and then here's the twin T, and I didn't put the diodes. I use the 1N5718 as a Schottky diode because they have a lower drop, but this circuit I found will run on like 5 volts, so it doesn't matter. Also, I measured the frequency out, and it's 456, which is close enough for what we're doing here. But I'm going to continue using my Heathkit oscillator because I have one measurement made where I fed the input to the bandpass demodulator, and I want to use that same output level. If I change oscillators, I'm going to get a different output. So what we're going to do is this. We've got another bandpass, and then we've got an amplifier. This is the V3, this 9018 here is an amplifier. This is a bandpass filter. And I guess that's it. It was pretty simple and straightforward to wire together. So here it is all wired up. Whoops, I better move these wire segments here. It'll ruin my day. Okay, so we're ready. What I've done is I've taken the white transformer and I've run the slug tuning. These are called tuning slugs to the top, and it winds up in this position. So let's see. Let me turn on the power supply. Let me turn on the receiver. And the last time I had the volume all the way up, so I'll turn the volume all the way up. Let's turn on the oscillator and turn on the modulation. And you can hear it. So let's start tuning down. There's one turn. Hear it getting louder. One and a half. Okay, just one and a half. Sounds like the peak right there. And you heard it go up when I... Okay, I just moved away anyway. So that was 1 and a smidge. Let's say another 1 and an eighth for that transformer. Now the signal is loud and it's distorted, and that's because the input signal is over driving the amplifier. So the receiver is getting more and more sensitive to any signal coming in as we add the IF stages in the IF amplifier. So let me set this thing right there, and I won't touch the signal generator. And then when we come and add the first IF, okay, then that's with the yellow IF transformer and a few more parts. That signal will be even more loud. So let's see, was there anything that I needed to tell you? I'm feeding the signal into this point. with that capacitor that I had here moved over here, and it solders to this pin of this IF transformer. Let me turn that off. No need competing with a tone. This junction here is from this pad to the trace that goes to the collector of V2, and so there's no dual pad there. It just connects direct to this point. So I just tack soldered, meaning using just a little bit of solder to tie the capacitor there to feed the signal in. There were no gotchas. You saw that, and that was pretty simple. Then now these things, the video for this one and then for the first IF stage these are going to be short, okay, because there's not much to do as long as you have the equipment. All right, I'll post this. I don't know how long it took me. I went off and came back and did this in short order. Oh, what took the time for me was building that little 455 kilohertz oscillator, and that took an hour and a half or so, and I just took my time. Also, the way that circuit is laid out with 68 picofarad caps, the oscillator really oscillates at 456 and some change, so not a biggie. All right, I'm going to go off and post this video. Then I'll come back and do the first IF. We're pretty close to getting an AM receiver going.